to today's video. So in this video we're going to cover the first dot point in the equilibrium module. So just basically this dot point just basically says model static and dynamic equilibrium and analyzes the differences between open and closed systems. So let's get started. So static equilibrium just basically means it's irreversible and the reaction goes to full completion. Then we have a dynamic equilibrium where the reaction is reversible and the reaction never goes to completion. So when most people imagine a chemical reaction, they often think of a situation where reaction occurs in one direction, where the reactants continue to produce products until the reactant is used up and the reaction stops. This is what we call a static equilibrium, but in most cases, um, the reactants and products will go backwards and forwards, thus giving us a dynamic equilibrium. Right, the products and the reactants do switch over from left to right, thus the reaction will never go to full completion. Thus we always use a double-sided arrow. So just basically dot point just states model. So I drew up a pretty dodgy model right here. So we have molecule A and B. So this is the products, and this is where the reactants in a static equilibrium, all the products turn into reactants. As you can see, in a dynamic equilibrium, some of the products do form, some of the products do not form, and these go backwards and forwards, which I forgot to do a backwards arrow. So just kind of every model will be different, but just keep this model in your head. Static, all the products are used. Dynamic, the products are not completely used and these switch over. So next part of this dot point, let me scroll down. So we have an open system, right? So we have components can escape, which is a static equilibrium. You'll see this later on when I show you guys the model. So we have a closed system where components cannot escape. So again, I drew up a even dodgier diagram. So just basically, let's say a bottle of Coke, right? So in an opened system, right, carbon dioxide will escape into the environment. It has a place to escape. Thus, it is an open system. This is a static um, equilibrium. Then we have a Coke bottle which the lid is closed. Thus, the system is closed, where the carbon dioxide forms and can go back into the liquid state, thus giving us a dynamic equilibrium. That was pretty simple dot point. So hopefully you guys enjoyed the video. Thank you for watching.